Okay, welcome to part 2. So, we were talking about asset storage and materials and renderers, and basically what happens when the serializer comes across an asset that it wants to save. So in this case, we're saving this mesh renderer, and it has materials, so we should serialize those materials. How does it do it? Well, it comes across this materials array and it serializes the materials array, and for each material it basically it looks up, it performs a lookup. It looks up to see if this asset is located in this asset storage here. If it is, we get the index or the key. We get a unique key for that asset, and we serialize the key, and then so that when we load it back, we basically deserialize the key and look up the key from the asset storage. Now I think this is a dictionary, and the keys are just the asset names. Yep, it's an asset lookup, basically a serializable dictionary. So this is one thing, which means that your assets have to have unique names. At least the assets that you want to say, they should have unique names. Okay, now let me clear this storage here and show you what happens, show you what I mean when I so I'm gonna hit save now, and so you see it added a cube, which is basically a mesh, and a material. This is because we're saving the mesh filter and the mesh renderer. Mesh filter references a mesh, and the mesh renderer references materials. So if we change the mesh to a cylinder and say loads back. Now let's mess with it a little bit. Let's say we change this. Let's make it I don't know, a capsule. So now when we load a capsule, because the mesh at cube is a capsule. Yeah. Did I say new go? Yeah. Okay. So you get the idea. Now, one thing about this asset storage, all the assets that you're referencing in your game should be available in the storage when you build your game, right? In other words, this storage here has to be populated when you run your game. And the way to populate it is just to simply play the game and trigger a save. Like initially, like you'll have an empty storage, so you just play your game and then hit a save, and when you do that, it gets populated with all the things that you're referencing. So that's an easy way to populate it, and you don't have to worry about you don't have to worry about triggering a save from inside of play mode. You're not gonna lose your changes because you're not saving into a scene object. You're saving into a scriptable asset, basically. So let me show you what I mean. If I enter play mode and save from then play mode, it populates the storage, and now when I get back, they still remain the same. They're not gonna go away because this is a persistent asset here. It's not like saving into a scene object, basically. Now, this is something we could argue about, this asset storage idea. Like, what if you had a big game and with multiple levels? Now, currently you only have a single asset storage, which means if you have like meshes or renderers or certain assets that are only available in the first level of your game, and the player is currently playing the last level, well, those assets in the first level are still going to be loaded or referenced in the asset storage. Now, this is something that you might not want to have. Basically, you don't want to have assets in your first level that are loaded during the time you play the last level of your game. So you might not want to have that happen. So what you can do is basically have multiple asset storages. Maybe a single one for each scene or something. I don't know. It depends on how you want to do it. If it turns out to be a problem for you, like right now, I'm just not sure. I just don't see it clearly being a huge problem. And one thing I learned the hard way is if you're not sure that a problem actually exists, if you don't see it clearly happening, if you don't see it clearly it exists, then don't solve it, basically. Because a lot of the times you end up wasting your time and effort solving a problem that doesn't exist. Solving something that you think that could be problematic, but most of the time it turns out not to be. So if it is a problem, we'll find a better solution, like multiple storages, or just find a way to filter out references that are not needed in the current scene or something like that. I don't know. But for now, it's just a single asset storage. And one other thing, like most of the times you're interested in saving like AI state, player position, data, and stuff like that. So if you're gonna be saving assets, they're not gonna be a lot. I don't know. I mean, at least for my needs. I mean, why would you fill like the asset storage with like hundreds and thousands of assets? Why do you need to save like? This is just an example. Like in practice, you're not gonna save mesh render. Like rarely do you ever need to do that. And even if you're gonna do that, it's not gonna be in large quantities. I don't know. Like I said, it's not so clear right now. This is why I'm making it like the FastSave open source, because I want to have the community's opinion and what you guys think, because together we can make this a better asset, a better system. Yeah. Asset storage. Yeah, so that's about it. I should go over the other test scenes. Let me just go over these limitations here. Like we've said before, assets should have unique names, and components that you're saving within game objects should be unique. Like, for example, in this case, we're saving this game object. It has a mesh renderer. It should have a single mesh renderer. It should have a single box collider. Like, it should have a single component of each type. Like, it shouldn't have two components of the same type. Right. So if you're saving the mesh renderer, it should have a single mesh renderer. It doesn't matter if you're not saving the component. Like if you had a marker and you're only saving transform. It doesn't matter if it had multiple mesh renderers or multiple colliders or multiple box colliders. You can't have multiple box colliders, but yeah, you get the idea. Like multiple some data scripts or whatever. It doesn't matter because you're only saving transform. So for components that you want to save, they must be unique in terms of their type. There's only single binary serializer right now. There's no interface with other serializers like JSON and stuff like that. Maybe in the future we make the API more flexible to accept other serializers. Now the way you add support to other components. If you go to fs common, it's actually pretty simple. So you have this common fs common class. This is where the initialization for the serializer happens. So we serialize the attributes. We tell the serializer what logic do we want to use. We're basically using the same logic from VFW, telling it when a field, what method to use, what predicate to use to determine if a field is serializable or not, and the same thing for a property. And then we have this explicit component serializer, which it's pretty simple. You just give it a component type and the names of the fields or properties within that type that you want to save. So in the case of transform, we're interested in position, Euler angles, and local scale. It might be better if we save rotation. I don't know. For now, all their Euler angles seem to be working fine. They're basically simpler. They're just a vector 3. So rigid body, we save mass, drag is kinematic, use gravity, and stuff like that. So if you wanted to add support for another component, you just go here and add, I don't know, something. I don't know, some component, and then the field names. So field 1, I don't know, field 2, and stuff like that. You don't have to add explicit support for your mono behaviors. That's because they're all serialized by a single serializer, so you don't have to add explicitly here, say add my custom script or something. You don't have to do that. They're all handled by a single reflective serializer. This is only useful if you want to add support to Unity's game objects, Unity's built-in game objects. You do it from here. So what I'm saying in this note, that the only way to add support to built-in components is if you go to that script and add the components by hand. So there's currently no way to extend it, you know, dynamically, let's say. But this is something that could easily be added in the future. There's no versioning backward type compatibility for the serializer. That's something important to keep in mind. So if you save your data to a file, change the signature yes, of your data. So if you saved a type called my script or my custom class, it had, let's say, an int x, y, and z, let's say. So you save it and then you change the format of your custom class, so it becomes I don't know, basically, let's say an x and y. So you remove z or remove x and z or y and z. Now when you try to load the data, well, you saved x, y, and z, but now you're loading into my custom class that only has an x. So what's gonna happen to x and y? There's gonna be an basically a data format mismatch, basically, between what you saved and what you loaded. So you're gonna have problems in that instance. Yeah, to make it work, you'd have to save your data again with the new format that you've changed into, with the new layout that you've changed into, and then when you load it, you know, it gets loaded with the most recent format that you saved, basically. The error coding, this is something I've been hesitant about. Like, I wasn't sure. Like, most of the save methods are void, basically. So save game object to memory or something. It might be useful if we added like some error code, so save status or something, which you could check to see errors and stuff like that. But like, I wasn't sure about that, because like, if we go with this approach, that means the whole API will be cluttered with these error codes. Even in areas where an error might not occur. So it adds this confusion where the user looks at the API and sees that it returns a save status, which means he might expect an error. Well, what if the method doesn't actually cause any errors? Then, like, the user will get confused. Like, does this actually return any errors? Like, should I check for the error code or something? Like, something like that. Bytes. And then do if code equals, I don't know, save result error or something. Should he do this, or should he not care about the error, or what should he do? Like, it adds this confusion to the API, so I'm not sure yet how to handle that. I mean, error codes are important, of course, but right now I'm just not sure. The way to check for errors now is just put it in a try and catch block. So save whatever to whatever. Yeah. Now, the last thing I want to go over is the hierarchy. You can save a hierarchy, basically. So, save hierarchy, load into a new hierarchy, get a new hierarchy. If we mess with any of the objects within that hierarchy, it's gonna come on. Red. Load into target. Interesting. What is going on? Oh, my bad. Excuse me. I was selecting this. Excuse me. Let me just Control Z, Control Z. Yeah, so everything's fine. I was, instead of dragging this one, I dragged this one. So, yeah, it's back. So yeah, pretty much the same concepts that we've talked about. Save hierarchy. So you say you could use the extension methods that we've talked about. So you say save hierarchy to memory, load hierarchy from memory, give it the bytes, new object, new game object, to a new instance here, to a new hierarchy. You give it the root. This is the root of your hierarchy. And yeah. Something to note about hierarchy saving is that I'm saving them top to bottom. So I save the root first, and then I go recursively down. This is also true for loading, which means if you have a hierarchy where you have a script somewhere at the top and it's referencing objects in a lower level on that hierarchy, you might have problems because, well, the first object that's going to be loaded is the top one. And if you're doing some initialization in a wake where you're referencing something like this, for example, something nested within that hierarchy, it's not going to work out very well because, well, we're going to initialize this game object, we're going to add the script, it's going to call a wake, but it's not going to find this nested game object because we haven't yet created it. You know what I mean? So we might provide a saving and loading hierarchy method where we specify whether we want it to save top to bottom or bottom to top. So yeah, but you should you only care about this if you're loading into a new hierarchy. If you're loading into the same hierarchy where you don't mess with the hierarchy itself, that's not going to be a problem because all the objects are still there. So even if you had a script here that references this object, for example, you mess with the hierarchy, you save it, and then when you load it back, assuming you have the same hierarchy, assuming that you haven't deleted, moved, or done anything to the hierarchy, it's gonna load successfully fine. So that's about hierarchy, and the last thing is marked. We've already talked about marked, but there's a pretty handy way to quickly save marked game objects. So here we have these three game objects that all of them have this FS marker, and then we have a game object that is not marked, so it doesn't have a marker. And then this test here again. All it does is just save marked and load marked. So save marked to memory, load marked from memory. Okay. Now what this does is basically find all the marked game objects in your scene and just saves them. And then when it loads, it tries to find the same game objects that it saved and load the data back into them. So I don't know, let's just hide this. I should have said save marked first. Yeah, and hit load, it loads them back. And notice this isn't getting loaded because it's not marked. So this is a quick way to just save certain marked game objects. Pretty handy way. And you can go over this example here. This saving and loading room example that I had. You can set it up using this save mechanism. So let me quickly. So I have 3 separate scenes. Each scene's saving a bunch of game objects. So here I'm saving this cube, this ball here, sphere. So if I mess with these and go back, notice it's basically back where I left the room, right? So this is how you could implement simple room loading and saving. Even if you change, like mess with the scale. Oh wow, wow. Okay, So if you mess with the scale or anything, go back. They're still back. They still have the right scale, the right material, the right whatever you decided to save, basically. And if I exit and run the scene again, they're still back the way we left them. In my case, I'm saving to file, so I can say reset the room data, which basically clears up the saving files. So when you load it back, it's back the way they initially was. So yeah, that's about it. Hope you find it useful. Let me know what you think. If you have any help, if you have any questions, suggestions, just let me know in the forums. And see you later.